Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use chain rule for derivatives to find the derivative of these three functions. So let's start with the first function. So the given function is f at x equals parentheses pi square minus x square exponent 3. Now for chain rule, we have to first identify the inner function and the outer function in these given functions. So in this first function, the inner function is pi square minus x square, that is in the parentheses. And the outer function is this exponential function for which the exponent is 3. So the first step in finding the derivative using the chain rule is to find the derivative of the outer function. So the first step is prime of f at x equals. Now the outer function here is this exponential function. So we'll use the power rule. So we'll move the exponent to the front and subtract 1 from the exponent. So pi square minus x square exponent 3 minus 1 times. Now we'll find the derivative of the inner function, which is pi square minus x square. Now pi square is a constant because pi has a fixed value, so the derivative of pi square is 0 minus. Now for x square, we can use the power rule to find the derivative, which is 2x. Now we can simplify this expression. So prime of f at x equals 3 parentheses pi square minus x square exponent 2 times negative 2x. Now we can combine 3 and negative 2x. So prime of x equals negative 6x, then pi square minus x square exponent 2. So this should be the final answer for the derivative of this first function. Now we can find the derivative of the second function. So the second function is y equals square root of x squared minus 3. Now this is a radical function. So the first step here is to change the radical into a rational exponent. So we can start here on the left side. So first we'll rewrite this function as x squared minus 3 in parentheses and then exponent 1 over 2. Now we have to identify the inner function and the outer function to apply chain rule. So the inner function is x squared minus 3 in the parentheses and the outer function is an exponential function with exponent 1 over 2. So as per chain rule, we start with the derivative of the outer function. So here we can use the prime notation. So y prime equals, so the outer function is the exponential function. So we'll use the power rule of derivatives. So we'll move the exponent to the front and we'll subtract 1 from the exponent times the derivative of the inner function, and the inner function is x squared minus 3. So the derivative of x squared is 2x as per the power rule, and the derivative of 3 is 0 because 3 is a constant. Now we have to simplify this expression. So we get y prime equals half and then x squared minus 3 and the exponent, so half minus 1 is equal to negative half times 2x, because 2x minus 0 is the same as 2x. Now we can move a step here. Now we can simplify this expression. See, x squared minus 3 has a negative exponent, and in our final answer we should not have a negative exponent, so we should move x squared minus 3 to the denominator. So we get y prime equals 1 over 2, and then parentheses x squared minus 3 exponent half times 2x. Now we can multiply these terms. So the denominator of 2x is 1. So when we multiply fractions, we multiply numerator terms and denominator terms. So we get 2x over 2 and then x squared minus 3 exponent half. Now we can cancel out the 2's. And in our final answer, we get x over. Now in the denominator, we can change the rational exponent half to square root. So we get x squared minus 3 with a square root. So this should be the final answer for the derivative of the second function using chain rule. Now we can find the derivative of the third function. So the third function is f of x equals 1 over x squared minus 16 exponent 5. Now this is a rational function. So x squared minus 16 exponent 5 is in the denominator. So the first step here we can do is to move this denominator to the numerator, and that will change the sign of the exponent. So f of x equals x squared minus 16 and then exponent negative 5. Since the numerator is just 1, so 1 times this expression will just be this expression. Now we can use the chain rule to find its derivative. So the inner function is x squared minus 16 and the outer function is the exponential function with the exponent negative 5. So as per chain rule, we start with the derivative of the outer function. So we'll move the exponent to the front to negative 5, then x squared minus 16, and we'll subtract 1 from the exponent times the derivative of the inner function, and the inner function is x squared minus 16. So the derivative of x squared is 2x as per the power rule, and the derivative of 16 is 0 because 16 is a constant. Now we can simplify this expression. So prime of f of x equals negative 5 and then x squared minus 16 exponent negative 6 and times 2x, because 2x minus 0 is equal to just 2x. Now we can multiply negative 5 by 2x, so we get prime of f of x equals, so negative 10x times x squared minus 16 exponent negative 6. Now we should not leave a negative exponent in our final answer, so we'll move the x squared minus 16 to the denominator, and that will make the exponent positive. So prime of f of x equals negative 10x over x squared minus 16 and then exponent 6. So this should be the final answer for the derivative of this third function. So these are the steps you have to keep in mind to use chain rule to find the derivatives of these three functions. So it's very important to identify the inner function and the outer function, and then use the chain rule to find the derivative of the function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.